This is Algebra 1, Lesson 10.1. We're adding and subtracting polynomials beginning on page 576. Got a bunch of definitions to start. First one is, what is a polynomial? First off, you need to understand what that prefix poly is. That means many. Many. It means many. Nomials is terms. So many terms, or many or more than one, is probably an easier way to say it. They give you a bunch of definition up here that says polynomial is an expression which is the sum of terms of the form a times k to the x, where k is a non-negative integer. Okay, all that's great. Many terms. Easiest way to remember that. Standard form. Standard form is not the same definition as a as an equation in standard form. Remember, an equation in standard form we said was ax plus by equals c. That's a different standard form. When you're talking about the standard form of a polynomial, all it says is that your exponents start with the largest exponent and count down. So x to the third plus x squared plus x to the first power plus a constant number like 1. That's considered standard form because 3, then 2, then 1, then 0. No variable term there. If they were out of order, then it would not be considered standard form. That's what standard form of a polynomial means. Then you have degrees and degrees of a polynomial. A degree is simply what is its exponent. If you have something that says x squared plus y to the third plus 4, if I ask you what is the degree of y, you're going to say y is to the third degree. What's its exponent? That's all that means. So when you see that word degree, that's all it means. What is its exponent? The degree of a polynomial is the largest one, whatever the largest one is. If you have it written in standard form, it'll be first because you're going to start with the largest one. Then you're going to follow with the ones that are smaller. So it'll be the first one. So if you're asked just for the degree of a term like y, its degree is 3. If you're asked for the degree of a polynomial, it's the largest one in the entire polynomial. We'll deal with them where we have more than just 3 things. The leading coefficient, you know what that word coefficient means? That's the number that is in front of the variable. So 2x plus 3x squared, these are coefficients, 2 and 3. The leading coefficient, if you write something again in standard form, is going to be the largest degree. This is the largest degree in this case, 2. So that one would be first, 3x squared, and then positive 2x. So your leading coefficient would be this number right here, 3. Leading coefficient. And then you have 3 terms: monomial, binomial, trinomial. Bi is an easy prefix for most people to understand because you grew up with bicycles and stuff like that. We're bipedal. That means you do 2 things, or there are 2 things. That's what bi means. 2 nomials, 2 terms. So something like x and negative 2. That is a binomial. Trinomial is just as easy to remember. You know what tricycles are. Uh, just like a bicycle, they have 3. Most of us probably didn't have a tricycle, or we had one of those power wheels that was like a tricycle or something like that. That was as close as we got. But a trinomial, you know the prefix tri means 3. 1, 2, 3. So like x squared plus x plus 3. That is a trinomial. There are 3 terms. Remember, terms are separated with addition or subtraction between them. And then a monomial is something that is only one term. Mon or monomial, mono right there means 1. Bi is 2, tri is 3. That's easy. So something like this, negative 3x squared y z to the 4th. That is a monomial. Don't confuse yourself. Notice, even though there are clearly four things up there, a negative 3, an x squared, a y, and a z to the fourth. That's four things. They're not separated by addition or subtraction. So that's one term. That is a monomial. Monomial, binomial, trinomial. Nobody ever messes that up. You ought to be fine on that. Here's example number one. Identifying polynomial coefficients. Identify the coefficients of x plus 3x to the fourth minus 11x to the third minus 9. So remember, if there's no number written, we know that there is an understood 1 right there. So if you identify all four of these coefficients, you have a 1 right here. That's one of them, 1. The next coefficient is 3. The next one, don't forget the sign that goes with it, is negative 11. And the last one is the same thing with the sign, negative 9. So 3x, this is just rewriting it in standard form. Notice the one thing that's added in here. If it's in standard form, it goes from 4 to 3 to 1. There is no second degree. So what we included here was 0 second degrees. There are none, but it's a placeholder. Then all of your coefficients are the ones that go with it. 3, the ones I have underlined, negative 11, 1 and negative 9, and 0 is included because it's coefficient of x squared. On the back or on the side, identify these coefficients. Remember to include every degree. Rewrite it in standard form and include every degree. Don't skip one. Even if it's not up there, don't skip it. So first things first, let's rewrite it in standard form. Put the biggest degree first. The largest degree or the largest exponent is the third one right there. That's positive 2x to the third. The next degree is x to the first power. So that's negative x to the first power. And the last degree shown is a degree of 0. There's no variable there. Positive 4. So notice, though, that between x to the third and x to the first, it skipped x to the second power. So anytime you skip a degree like that, you need to put in its coefficient as 0x squared. Now it's written in standard form. Positive 2x cubed plus 0x squared minus x plus 4. Then you're just identifying what are all of the coefficients. 2, 0. What's this coefficient? Negative 1. Don't forget there's a 1 right there. And then the last one, 4. Those are the four coefficients. Make sure you don't forget or don't leave out the 0 for the second degree, x squared. This is simple. The next thing is classifying polynomials. We can classify them three different ways up here. We can classify it by degree, or it labeling its degree, then classifying by its degree, and then classifying by how many terms it has. The first one, there's no variable after the negative 3. Therefore, its degree is 0. It's considered a constant term, and it only has one thing, so it's a monomial. So this is considered a constant monomial with a degree of 0. What is the largest exponent of the second one? It says negative x plus 1. What's its exponent? Right here. It's not shown what goes there. 1. So its degree is going to be 1 when something has a degree of 1, like y equals mx plus b. Everything we've learned in here so far, it is considered a linear. You classify it as linear. How many terms do they have up here? There's 2 of them right there. So that is a binomial. Its degree is 1. It is a linear expression, and it is a binomial. How many terms are in the next one? 2. So that one's going to be a binomial 2. What's its degree, though? 2. Remember, it's the largest exponent. 2. So degree is 2. Terms are binomial. When something has 2 as its exponent, it is considered quadratic. Don't let that confuse you. Typically, that prefix quad means how many? 4. Don't let that confuse you. A quadratic is something that is x to the second power, or x squared. How many terms are in this next one? Yeah, it's 4. Remember, they're separated by addition and subtraction. I can count 1, 2, 3, 4 of them are separated. So when we go above 3, remember I gave you guys the definitions for for monomial, binomial, and trinomial. I didn't give you one for fourth, or 4 of them. It's a quadrinomial, I guess you can call it. But if we go above 3, we'll just simply call it a polynomial. We'll just give it a generic name, polynomial. What is its degree? What's the biggest exponent? 3, we can see it right there. Just find the biggest exponent. Remember, if it's not in standard form, find the largest one. So its degree is 3, and since its degree is 3, it is cubic. So a cubic polynomial. And then how many terms are in the last one? 3. Don't let that 4 confuse you. There's only 3 terms up there. 1, 2, 3 are separated by addition. Okay, but its degree is 4. That number, the largest exponent, 4, is its degree. So it's 4th degree, and it is quartic. It's considered quartic, but it is only a trinomial because there are only 3 terms. So 4th degree, quartic is 4th degree, just like cubic is 3rd degree, and quadratic is 2nd degree. But it is a trinomial because it only has 3 terms. Again, either in the margin or on the back. Let's do these. Let's classify this. Let's give the degree. Let's do the same 3 things we just did for the example. Just take a couple of seconds on each one of these. How many degrees does it have? What would you call it based on its degree? And what would you call it based on how many terms it has? Okay, what's its degree? Its degree is 0. It doesn't even have a variable, so its degree is 0. How would we classify it if its degree is 0? It's constant, constant. And how many terms is it? 1. So what do you call that? Monomial. So 0 is its degree, constant, monomial. What about this one? 1/4 x. Same thing, classify it all 3 ways. What's this one's degree? It's not 0 this time. What's the exponent on x? Remember, it's not shown, but it's considered to be 1. So its degree for this one is 1. What do we call this if we classify it by degree? Something to the first power is what? Linear. Good. It comes right off the example from a second ago. Linear. And then how many terms is it? Again, 1. So what do you call that? Monomial, everybody. That's monomial. What about this one right here? Negative 9x plus 2. Okay, what's the biggest exponent? What's its degree? 1. So again, its degree is 1. So something to the first power is considered what? Again, linear, just like the last one. This one's linear. But how many terms do we classify it as? There's 2 of them. Binomial for this one. Binomial. And then what about this last one? X squared minus 6. What is the degree of this one? 2. So if something is the second degree, what do you call that? Quadratic. Remember, don't get confused. That doesn't mean 4. Quadratic. And then how many terms is it? Since there's 2, binomial. So second degree, quadratic, binomial. Example number 3 is adding polynomials. What you need to know about polynomials when you add them is that you can only add like terms. In order to be a like term, it does not have to have the same coefficient. It has to have the exact same variable raised to the exact same exponent. So for this first one, notice how they stack these on top of each other. X to the 5th is the largest degree. And then there's a space right here because there's no x to the 4th. That's just like having 0 as a coefficient. Then negative 3x cubed, then 11x squared, then negative 8x, then 2. Same thing on the second one. There's no x to the 5th, but they got an x to the 4th. Then the third, second, first, and third. And then 0, I mean. So all of those are in standard form stacked on top of each other. So when you put x to the 5th together with nothing here, you get x to the 5th. When you put nothing together with negative 2x to the 4th, you get negative 2x to the 4th. When you put negative 3x to the 3rd and positive 7x to the 3rd, you keep x to the 3rd and you add negative 3 and positive 7, and you get positive 4x to the 3rd. When you put 11 and positive 12 together, again, you keep x squared. You put those two together and you get 23x squared. When you put negative 8 and positive 8 together, you get 0x. That's why they put a little blank there. And then when you put 2 and negative 3 together, you get negative 1. So there it is added up. When you put those two polynomials together, x to the 5th minus 2x to the 4th plus 4x to the 3rd plus 23x squared minus 1. And then one more time, everybody on the back. Let's find the sum of these 3 polynomials. You do it exactly like 2. Very, very simple. Start with the biggest degree and work your way to the smallest degree.